working with Ebrahim and Fattane on this basically approach. So what this is the point of interest recommendation using heterogeneous link prediction. So I'll go through every detail in this presentation. First of all, I'm going to give you the outline that what we will cover in this presentation. First of all, I will give you the problem. What is the problem? The approach that we've actually done, and the evaluation with other models and the results that we've achieved. So first of all, you guys are probably are social networks users. So you do check-ins. Hossein, I know, does a lot of check-ins using his Facebook.
I don't check in.
You don't check in. So basically, the idea of checking in is basically when you visit a location, you guys are, you look that location up using the GPS coordinates of your phone, and then you perform a check-in on that location. And usually you make a comment about that place, or you make a review. It depends on the social network that you use. But these are the location-based social networks that we have as an example, and our main focus is on Google. Well, unfortunately, Google is closed, but our data set is from Google. So the idea of this check-in, as I explained, is this is, for example, the Google app that shows you the nearby locations. For example, La Rosa's, Hong Kong, Grand Buffet, whatever that is closest to you. But what is missing in these is location recommendation. So they show you the nearest location in whatever platform you're using, but in order to get a recommendation of the locations, that's missing. So that was the recent researchers in this field. A lot of scientists they have covered this recommendation using different approaches. For example, this is a location recommendation list for myself. Usually I go to Ryerson. I have a lot of check-ins in these locations. Galaxy Empress Walk, which is near my house. St. Hornos at Steels, which is again near my place, and that's LS3, of course, and Hangar, which is a field that I play soccer at. So this is, for example, a personalized location recommendation list. Everything's clear? Okay. So when we want to come up with an approach, usually we look at what we have and what features we have for recommending, predicting, or whatever we want to focus on. So if you look at the check-in, we see that we have 4 features that are important. One of them is venue ID, so the ID of the venue that you have visited. Another one, the user ID, the ID of yourself or whatever users you're looking at. For example, in Facebook, you have ID of myself, Alireza Pourali. So that's just simple IDs. Another one is categories. So each location is under a category. So for example, Ryerson is under university category, education category. Tim Hortons is under food category. So all of these locations are categorized. Another one is addresses. So all of the locations, of course, have an address. But the address that we actually extract from all of these check-ins and all of these locations is the longitude and latitude of those locations. So the world coordinates. Is that clear? Okay. So I'm gonna cover in this section our approach of what, in which way we have done the location recommendation. So we've used the link prediction. Basically, link prediction has been used for a lot of basically recommendations, such as, for example, co-author relationships. If you guys have read that paper. So basically the idea that they had was predicting which authors will be collaborating in future based on the links that was extracted from their network. So the whole idea is predicting links or interactions between objects in a network. So let's say this is our whole network. As you can see, those yellow lines are predicted in future. So using that, we actually constructed a graph, a network of users, venues, categories, and regions. So what does this mean? As I covered previously, we have used those features and we've came up with a graph of basically a network of heterogeneous network of users, venues, and categories. So as you can see, there is a link between user and venue using different ways. So for example, I have a direct link with a venue. I have a direct link with the friends of my friends with a venue. For example, if me and Howard if we are friends in a social network, if Howard visits a place, there may be a chance that I visit that place too, correct? So that's done by using this relation. So these are all nodes user, venue, category, regions. And the connection between these two is called the relation between these. So user has a relationship with venue of check-in. Venue has a relationship with category of belong to. So this is a simple idea. So as I said, these nodes, nodes is basically the IDs of the users. Venues is the IDs of the venues. Categories is what category each location is under of. And region, what this region is. I'll cover that basically in this example. So let's say there is like 3 check-ins here and 5 check-ins there. Those are all regions. These are just like X means cluster. Does that make sense? Did you guys get this part? The region idea. So the region of Ryerson is Timor, for example, this region is Ryerson, Timordone's SLC, for example, EPH. But there is another region that I have near my house, which is in the Cineplex, Empress Walk, my house itself, for example, Tim Hortons that is near my place. So these are all clusters. Yeah.
So regions are categorized and clustered and categorized for each and every single user?
Yeah. No. It's on the whole data set. That was my idea also when I talked with Ebrahim and Fattane. But it was performing better this way.
Okay.
I think using that idea, it would be more regions. So sometimes more data is not actually helping, right? Mm-hmm. So maybe simpler solution helps.
So the problem is not that of sparsity. It's it just makes it more complex.
Yeah. But we haven't tried that. I was thinking of trying that too, but. There would be, actually I think in that way there would be more personalized regions, right? But we haven't tried that because we only got good results with this. So maybe in future we can cover that as well. But I talked to Ebrahim about that, he suggested on the whole data set. Okay? So you guys got what are the nodes that we have, and we have the relations as I explained. User with user is just friendship connections. Venue with categories, what category that venue belongs to. Venue and regions, which regions are under which venues are under which regions, and the user venue is just a check-in connection. So I'm going to ask you about this. Can you find some meta paths find some paths between user and venue? Just give me some examples. Just some paths between user and venue. This is a path for sure, right?
User to venue.
But that's the simplest.
And friend to venue.
So just say UV, something like that. UV or
UV, or U, and any. Wow, it would be recursively U and then V, and also UV.
There can be also more. So that's the whole idea. You can also have UV and then RV. So you can basically say, okay, at the end the target will be V, user and venue. Source will be user, target will be venue, right? But what is in basically in between doesn't matter if you have reputations.
So cycles are permitted.
So if you go from user to venue, and then category to venue, that will give you a value for actually predicting.
Yeah.
So do you get that? We will have a lot of meta paths. So these paths are basically called meta paths between user and venue. So I have an example of meta paths right here. We have UUV, as you said. A user visits a venue where her friends has visited, and then UVCV, UVRV, whatever. You can come up with anything. You can come up with UUVRV. The whole idea is basically finding all of these connections. And then, as I'm going to explain here, a topological feature between these connections. So what are these is basically, we have our source node and our target node, and then we want to find the degree-weighted path count. That's just a feature that is used to learn a logistic regression feature, logistic regression model to actually predict, classifier to actually predict the future check-ins. So I'm going to explain about that in the next slide. But do you get how actually each node has, for example, different connections between, for example, from U to V, there's 2 connections between U to V at this point. So there's 2 connections coming. That's the edge of the nodes. I hope I explained this well. If you have questions, ask me now, because this is basically telling you, okay, from this whatever middle paths that you have at this section, there is a topological feature that's from that source to that target.
That's the degree.
That's the degree-weighted path count. So this is how the degree-weighted path counts are extracted. Basically, this is used to actually train the logistic regression classifier.